Okay, so let's work a few problems out from chapter 4, and this presentation will cover sections 4.2, 3, 4, and 5, and then the second recording for chapter 4 problems will cover the remaining sections because it's a pretty long one. So in this section, I am going to solve a few problems, namely from valence electrons, formation of ions, and ionic charge, sign and magnitude, how to figure those out. Okay, so let's get started with the first problem that's on page 106 of our textbook, and this namely is problem 4.3. Says how many valence electrons do atoms with the following electronic configurations have? Before we get started with the problem, I think it's a good question, it's a good thing for us to take a minute and understand what is meant by valence electrons. So, if you remember, valence electrons are defined as number of electrons or all the electrons that are in the valence shell. The valence shell is the outermost shell. In other words, the shell of electrons that has the highest shell number. So if you look at the electronic configurations in this problem, the first one, A, the configuration is 1s2, 2s2. In other words, the first shell is the one with number 1, and the second shell is the one with number 2. Which shell of the two is the outermost shell? Which shell of the two is farthest away from the nucleus? The answer to that question is shell number 2 is the outermost shell for this atom. If that is the case, if the valence shell for the first atom is shell number 2, then how many electrons are present in this second shell? The answer to that is 2, because there's only S subshell for this particular atom. So this atom has 2 valence electrons, and of course both of those 2 valence electrons are in the S subshell. Using the same logic, if you look at the next electronic configuration, take a second to think about and tell me which is the valence shell, which is the outermost shell. Yes, the outermost shell, once again, is the shell with the highest shell number, which in this case is the 4th shell, and then look at the electronic configuration and figure out what is the total number of electrons in this shell. Yes, you're right. This particular valence shell for this atom has a total of 4 electrons in the valence shell. 2 of those electrons are in the 4s subshell, and the remaining 2 are in the 4p subshell. But the number of valence electrons is 4. Okay, problem 4.5 on the same page of the textbook now asks you to determine the number of valence electrons present in the atoms listed below. I just selected 3 of the 4 given. The logic is the same for all of them. I think it is important to note and to remember that a very easy way and a very quick way of determining the valence shell and valence electrons for representative elements. If you do not remember what representative elements are, you need to go back in and check that out. So for representative elements, the group number is equal to the valence electrons for those elements, and the period number is equal to the valence shell in which these valence electrons live. I would also like to point out to you that when you're looking at the group numbers in order to determine valence electrons for the representative elements, you need to look at the Roman numerals in the periodic table. If the periodic table in front of you does not have the Roman numerals, then it may be a good idea to actually write those down and do that very carefully. Please go back to the previous chapter and look that up. Anyways, moving on. So, as I said, the Roman number, group number for each element for the representative category gives us the valence electrons, and the period number, which is the rows, gives us the valence shell. So if you look at neon, check your periodic table, and then decide which group neon exists in. Neon is a noble gas, and the group number for this element, and remember we are using the Roman numerals only, group number is 8A. In other words, since the group number is 8, the number of valence electrons in this element is also 8. The outermost shell for neon will consist of 8 electrons. Now, just FYI, which shell is the valence shell for neon? You're right. Since neon lives in the second row or the second period, that means it's the second shell which is going to be the valence shell, and the second shell in this case will have 8 electrons. So, using that same logic, let's do this very quickly. Calcium. Calcium is an alkaline earth element. It exists in group 2A. In other words, since it exists in group 2A, the number of valence electrons for this element is 2. Iodine is a halogen, and it exists in group 7A, and hence the number of valence electrons for iodine will be 7. So the key thing to remember in this is that the number of valence electrons equals the group number for the representative elements. Sorry. There we go. Okay, so let's move on to the next problem. Write the complete electron configuration for each of the following representative elements. Complete electronic configuration for each of the following representative elements. Okay, so there are a few things that you have to do before you start. First of all, the question tells us that the element belongs to period 2. If it belongs to period 2, and also it says that the element has 4 valence electrons. The fact that the element has 4 valence electrons implies that the element belongs to group 4A. Once again, Roman numeral 4A. Now, if you look at your periodic table, which element is the one that's in period 2, group 4A? Absolutely, it's carbon. So in this case, the element is carbon. Now, the Z value for carbon is 6. So we are now ready to write the electronic configuration. So if you start writing the configuration, you start with 1s2, 2s2, 2p, absolutely, 2p2. So here is your valence shell with 4 valence electrons in the second shell for carbon. In exactly the same way, once again, period 3 element that has 2 valence electrons. If it has 2 valence electrons, it means that this element belongs to group 2A. Which element would that be? Absolutely right. This element here is magnesium. Magnesium with a Z value of 12. So let's start writing electronic configuration. So starts 1s2, 2s2, 2p6, and then 3s2, 3s2. Count your electrons. Make sure we have written down all the electrons. So that's 2 plus 2 plus 6, 12, right there. And this is the valence shell, the third shell. The next question asks us to determine each element's identity if their Lewis symbols are given. So this is problem 4.15. So in this case, the first element X is shown in the question, which is not showing on the PowerPoint, but it shows in the question as having 1 electron in its Lewis symbol, and B is showing to have 7 Let me write this again because I'm going to run out of space, I know. Okay, 7 electrons. So the question is like that. It's giving us Lewis symbols of 2 elements, and it's asking us what are these 2 elements as long as they belong to period 2. So once again, remember that the Lewis symbols only shows the valence electrons as dots around the elemental symbol. So if looking at part A, if the element X has only 1 valence electron, that tells me that this element belongs to group 1A. And the fact that it is in period 2, I need to now look at my periodic table and look at which element is in period 2 and group 1A. If I do that, the answer comes out as lithium. Lithium, Li, will have a Lewis dot symbol of Li with 1 dot showing 1 electron. Exactly the same way, now we are looking at, in part B, an atom that is in period 2 but has 7 valence electrons. Because it has 7 valence electrons, this element belongs to 7A, group 7A. And the element in group 7A and in period 2 is fluorine. Fluorine element will have 7 electrons, valence electrons around it. So it's really as simple as that. Please remember, period number gives us the valence shell, and group number, the Roman numbers, give us the valence electrons for representative elements only. Okay, draw the Lewis symbols. Now we are doing the reverse here. If we know the electron configuration, can you draw the Lewis symbol? Now, first we need to figure out here what element is it. So there are a few different ways of doing it. Yes, you could count all the electrons. You could count the electrons, figure out what the total is. In this case, the total is 12, which means Z is 12. Look in the periodic table, and that tells us it has to be magnesium, because magnesium has a Z value of 12. Next thing to do would be checking the electronic configuration and trying to figure out how many valence electrons does this atom have. So magnesium, according to the electronic configuration and also according to where magnesium is in the periodic table, has 2 valence electrons. So as soon as you put those 2 valence electrons there, here is your Lewis symbol. Following exactly the same logic, now this element belongs to period 4 because the valence shell is 4. This element has 4 valence electrons. That means it belongs to group 4A. So the element that is in period 4 and group 4A is germanium, Ge. Ge, and the valence electrons are 4 valence electrons. Here's your Lewis dot symbol for germanium. Let's confirm that this is indeed the case. So count the total number of electrons. Let's do that. Let's take a few seconds. I came up with 32 electrons total, and the Z value for germanium is also 32, so my answer is correct. This element indeed is germanium with 4 valence electrons. Okay, let's now talk about ions, because that is really the focus of this chapter, is to show how ions are made and therefore how ionic compounds are made. So very quick reminder, ions are made when atoms lose or gain electrons. When they lose or gain electrons, then the total positive charge coming from the protons is no longer equal to the total negative charge coming from the electrons. When there is this imbalance of total plus and total minus, there is therefore an overall residual charge on the particle. Those particles that have overall residual charge are called ions. So cations, meaning ions with plus charge, are formed when electrons are lost, because then there are more protons than electrons. Anions or negative ions are formed when electrons are added, when they are gained, because then there are more electrons than protons. So that's the basic idea here. Now let's look at problem 25, and it says, what would be the chemical symbol for an ion with each of the following numbers of protons and electrons? So basically what you need to figure out in this problem is, what is the total plus coming from protons? Each proton has plus 1 charge, therefore 20 protons will have 20 plus charge. What is the total negative coming from the electrons? Each electron is minus 1, so 18 electrons will be 18 minus. So if you put these two types of particles together, what is the overall charge in this particle? So 20 plus 18 minus, what is the charge? The charge, you're right, the charge in this case will be 2 plus. Great. So we know that the charge is 2 plus. Now which atom is it that's making this ion? Which atom is losing electrons, 2 electrons in this case, to make this ion? So please remember that the Z value for an atom is really the identifier of the element. Z value equals number of protons. So since there are 20 protons, the Z value for this atom, the Z value for this atom is 20. If you look at the periodic table, which atom has a Z value of 20? Yes, you're right, it's calcium. So this ion that we are talking about is calcium ion with a charge of 2 plus. Let's do the same for the next one. Once again, 8 protons. If 8 is protons, that means the Z value is 8. And if the Z value is 8, we are talking about oxygen atom in this case. So that's number one. Second thing, let's talk about the total pluses and the total minuses. If there are 8 protons, then the total plus is 8 plus. And if there are 10 electrons, the total negative is 10 minus. So what is 8 plus plus 10 minus? Gives us 2 minus. So the ion in this question is oxide ion or oxygen anion with a charge of 2 minus. Okay, let's move on. Now it's asking us to do the opposite. Given the ion, can we come up with the number of protons and electrons in each of these ions? So the process is exactly the same. Instead, it's in reverse order. Number one, phosphorus. If phosphorus is the ion that we're talking about, in other words, Z is equal to 15. If Z is equal to 15, then number of protons is equal to 15. Now, if there are 15 protons, which basically means that the total plus charge is 15. But note that this ion has a 3 minus overall charge. The only way an ion can have a negative charge is if the number of electrons is higher than the number of protons. So the fact that this ion has 3 minus, that tells us that the number of electrons in this ion is equal to 15 plus 3, which gives us 18 minus. And I hope you can see that 15 plus 18 minus gives us a residual charge of 3 minus. So to answer this question, the number of protons in this ion are 15, because that's the Z value. Number of electrons is 18, because by doing so, the overall charge is 3 minus. Same thing, next one also. So magnesium, Z is 12 for magnesium. So number of protons is 12, which means the total plus charge is 12. And since now the charge is plus 2, meaning that 2 electrons were lost. That is the reason why there's an overall charge of plus 2, because now there are 2 extra protons, more protons than electrons. So if 2 electrons were lost, starting with 12 in an atom, then now there are 10 electrons only. Double check your work, because if there are 12 protons, which means the total positive charge is 12 plus. If there are 10 electrons, which means the total negative charge is 10 minus, which therefore gives us an overall charge of 2 plus, which is exactly what this ion has. So number of protons in this case is 12. Number of electrons in this case is 10. Indicate whether each of the following atoms or ions is neutral, negatively charged, or positively charged species. Okay, so once again, same idea. If protons equals number of electrons, there is no charge, it's neutral. If protons is higher than electrons, there's a positive charge, cation. If electrons is higher than protons, then there's a negative charge. So if something contains 5 protons, 5 electrons, we really do not need to consider or think about the neutrons here, because neutrons do not have a charge. So if there are 5 protons and 5 electrons, there is 5 plus and 5 minus. What is the overall charge? You're right. Overall charge for this particle is 0. It is neutral. It's an atom. Atoms are neutral because number of protons equals number of electrons. The next section says 36 electrons and 37 protons. Once again, neutrons is FII. We really do not need it here. So there are 36 minus and 37 plus. Sorry, plus. If that's the case, the overall charge will be plus 1. So this particle is a positively charged particle. Okay. Next one. Identify each element X by giving its chemical symbol based on the following information about an ion that it forms. So this particular element X makes a 2 plus cation. In other words, if it makes a 2 plus cation and it has 10 electrons, the fact that it makes a 2 plus cation tells me that it lost 2 electrons from the atom. Whatever the atom was, that atom lost 2 electrons. Now, if you look at the periodic table, which atom in the periodic table, well, there are different ways to do it. Okay, let's do the easy way. So, as I said, the fact that it has 2 plus charge means that it lost 2 electrons in order to make this cation. If after losing 2 electrons, it has 10 electrons left, how many electrons, therefore, did the atom have? Electrons in the atom. How many electrons did it have before it lost those 2? Of course, 12. So, if an atom has 12 electrons, it should also have 12 protons. And if an atom has 12 protons, that is the Z value of that atom. So once again, look at the periodic table and decide which element in the periodic table has a Z equal to 12. The answer is magnesium. Okay, let's do the same here. Now this is a 3 minus ion and it has 18 electrons. If this element has a 3 minus charge, in other words, it gained 3 electrons. So the electrons in the atom before it made the ion will now be 18 minus 3 equals. And if that's the case, for an atom, please remember the number of electrons equals the number of protons. So the protons in this case will also be 15, which means the Z value for this atom is 15. And that atom will be phosphorus, because phosphorus has a Z value of 15. Okay, indicate the number of electrons lost or gained when each of the following forms an ion. Now this is using octet rule, which says that atoms either lose or gain electrons in order to achieve a noble gas octet, to have an octet in their valence shell. Also remember that the capacity for the first shell is just 2. So octet rule basically says atoms lose or gain electrons in order to have 8 in the valence shell, or 2 if the valence shell is the first shell. Okay, so let's look at beryllium. Beryllium has a total of 4 electrons because its Z value is 4. Now, it has 4 electrons. The valence electrons are 2. These valence electrons, please remember, are in the second shell. The valence shell is shell number 2. Now, maybe I should do this. Maybe I should draw the first shell for beryllium, the second shell for beryllium. The first shell has 2 electrons and the second shell also has 2. The valence shell is shell number 2. Beryllium can do one of two things. Beryllium could either lose 2 electrons. If it lost 2 electrons, if it lost the 2 valence electrons, what is it left with? It is then left with just the first shell. The second shell is gone. The first shell now has 2 electrons. The capacity for the first shell is 2. So this tells us that the first shell, which is now the new valence shell, is 4. That satisfies the octet rule. If this were to happen, beryllium, because it started with 4 electrons, now has 2. It still has, this started with 4 protons and 4 electrons. After losing 2 electrons, it now has 2 electrons, but it still has 4 protons. Since it still has 4 protons, the overall charge on this new particle is 2+. That's one option that beryllium has, is that it can make a beryllium 2+ ion. The second option that beryllium has, that it could, instead of losing the valence 2 electrons, it could gain 6 electrons from somewhere. If it did gain 6 electrons, yes, the first shell already has 2 electrons, and now the second shell has its original 2 electrons and also the 6 shared ones. The 6 new ones. If you look at this particle, the valence shell is full. It satisfies octet rule. But the number of protons originally were 4, and that doesn't change. We are making no changes to that. But now the number of electrons is 10. So the overall charge, if this were to happen, the overall charge for beryllium, for this particle, would be beryllium with a charge of 6-. So beryllium has a choice of doing one of these two things. The decision we have to make is which of these two things is which of these two things will happen energetically. The key thing to remember there is whichever pathway is easier is the one that will be followed. In other words, whichever pathway involves fewer number of electrons being lost or gained is the preferred pathway. So, given that logic, beryllium does not gain 6 electrons. Instead, it always loses 2 electrons to make a beryllium 2+ ion. Beryllium is also a metal, which also means that it's going to lose electrons, and it's in group 2A. Since it has 2 valence electrons, it will lose both of its valence electrons to make that cation. Using the same logic for bromine, once again, bromine has 7 valence electrons to start with. It could either lose all 7 electrons, and if it did that, it will make a bromine 7+ cation, or it could gain 1 electron, and if it did that, it would have a bromine -1, and it would make a bromine -1 anion. Once again, same idea. fewer electrons, less work, less energy being used, and therefore preferred pathway. So bromine makes that anion by losing one electron. If you look at the periodic table, bromine is a halogen, it's a non-metal. It is in group 7A. In other words, it takes one more electron for it to have an octet, and therefore it gains one electron. In what group of the periodic table would representative elements that form these ions would be found? Okay, so a few generalities may be in order to mention here. So let me try and do that. Number one, metals always lose electrons when they make ions. They never gain electrons. The point number two, that the number of electrons lost equals, equals number, one more time, I apologize, equals the group number. And please remember, it's the Roman numbers that we are using. So that's for metals. For non-metals, on the other hand, when non-metals make ionic compound, they always do so by gaining electrons. When they are making ionic compounds, they never lose electrons, they never become cations. And number two, number of electrons gained by these non-metallic ions will be equal to group number minus 8. So whatever extra electrons are needed in order to get to the closest noble gas is how many electrons these atoms will gain. So for an ion to be making a -3 charged, to have a -3 charge, first of all tells me that the element is a non-metallic element, because metallic elements do not make anions. Second thing is that if this ion was created by gaining 3 electrons, that means this atom is present in, so group number -8 equals -3. If that's the case, group number is equal to -3 plus 8 gives us 5. This element is in group 5A of the periodic table. So the answer to this question is group 5A. Next one, +1 charge. It's a cation, +1. In other words, electrons were lost. Therefore, this must be a metallic element. It cannot be a non-metallic element. If it's a metallic element and electrons were lost, which tells me that the number of electrons lost is equal to number of electrons lost equals the group number, which means that this element belongs to group 1A. So keeping these general guidelines in mind, if you do, then the answers to these problems become very convenient to come up with.